Now let's talk about SSM, Systems Manager. Okay, so SSM, which is a huge service, which takes a much bigger piece of the exam in the SysOps or the DevOps exam. But still, there is a few aspects of Systems Manager you need to know going into the Solution Architect Professional exam. So, System Manager will help you manage your EC2 instances, fleet, or your on-premise systems at a scale. And if I give you some operational insights about the state of your infrastructure and things which you can easily detect problems in advance, and if you wanted to patch your entire fleet of instances, then you would use Systems Manager. And this is one big aspect of SSM at the Solution Architect Professional exam. And we'll see in details how patching works, because you have to remember all the steps. It works for both Windows and Linux operating systems and has integration with CloudWatch, metrics, dashboards, AWS Config. If you want to track the config every time of your instances, and it's a free service, AWS Systems Manager. Okay, so now let's do a deep dive into what SSM has to offer us. Okay, so we have resources, resource groups, and insights, which give you the inside dashboard and the inventory to discover and audit the software installed, and inside also give you some aspects around the compliance of your patching. Parameter store is more important, so whatever is important then put in have been put in the bold, and then this is what we'll do a deep dive on in this lecture. So the parameter store will help you store parameters and encrypt them if necessary. Actions is very important, so automation, if you wanted to shut down EC2 instances or create AMIs automatically, run command to like on your fleet entirely without needing SSH access, session managers to get into like an SSH session into your EC2 instances, and most importantly in the private EC2 instances. Like if you are using the Bastion, that's good, but if you're not using Bastion, then session manager is going to help you to get into those EC2 instances through SSH access. And but actually without using SSH, the session manager, without using SSH. Patch manager to patch your instances at a scale, so we'll do a deep dive on that, and maintenance maintenance of the Windows to see how we can apply either a run command or patch manager at a scale without interrupting your entire fleet of managed instances. Finally, there is a state manager to define and maintain application configuration of OS and application. So bottom line is there is a lot of services, and we give a little time, and we have to do a deep dive on the parameter store, run command, and patch manager and maintenance windows. So let's go ahead with first of all how actually the system manager work. So how does system manager work? You have the SSM service, and then you need to install the SSM agent onto the systems we want to control, and this include our on-premise instances, our EC2 instances, and it can work by default if you are using an Amazon Linux or Amazon AMI, Amazon Linux AMI, or some Ubuntu AMI. And some Ubuntu AMI. So otherwise, you have to go ahead and install the agent yourself with some of the on-premise instances. So the SSM agent will be installed onto your EC2 instances or your on-premise virtual machines, and it will talk with the SSM service to register the agent to the service. And if we have an issue with an instance, if we have some issue, so this is the on-premise instances have been hidden by my view. So if you have an issue with an instance that cannot be controlled by the SSM, and that's probably an issue with the SSM agent. So either it's badly configured, or we haven't made sure that the EC2 instances have a proper IAM role to allow SSM actions. So as you can see, because our EC2 instances have the SSM agent on it, and it talks with the SSM service, where we need to define an instance role for EC2 that allows the agent to talk to the SSM. Now that makes sense. So as soon as we have all our EC2 instances and on-premise virtual machines that have the SSM agent properly configured and integrated with the SSM service, we can go ahead and leverage SSM at its fullest. The first One is going to be we'll be discussing the run command here. So the run command is actually very explicit. It allows you to run commands. So these commands can be document a script, just one command. You can run commands across multiple instances by grouping them into resource group, and then you can control the rates at which the command is going to be run in terms of some errors are coming back, and you can also stop the run command execution altogether. It's going to be integrated with IAM and a CloudTrail, so that it gives you some audit and some security and make sure that the people can run the commands in SSM, but you can analyze it and audit it through CloudTrail. The cool thing about the run command is that we don't need SSH access. Okay, so the idea is that the SSM agent is going to run the command for us, and we don't need the SSH access to our instance. So that gives a lot more security from any realistic point. The results are also going to be displayed in the console if you want the summary. So let's have a look. We have EC2 instance, an EC2 instance that we don't need any SSH access, and because we have installed the SSM agent on it. Okay, and remember, the SSM agent is going to be talking to the SSM service, and they are communicating quite often. Now when we issue a run command from the SSM, it's going to be sent all the way to the SSM agents, and we don't need to have SSH here. The SSM agent will be able to find the run command and run it itself, and then SSM agent is going to run the command directly onto the EC2 instance. And so the cool thing here is that we don't need SSH, and then we get this audit through CloudTrail. Okay, so next, how do we patch a bunch of EC2 instances through SSM Patch Manager? So the first thing you need to know is that you need to define a patch baseline. And so patching baseline will allow you to understand which patches should or should not be installed on your instances. So let's go over the different patch baseline. They are predefined by AWS, and you need to remember how they are named. So AWS Amazon X2 Linux 2 are default patch baseline. Then we have AWS CentOS default patch baseline, AWS Red Hat default patch baseline, AWS SUSE default patch baseline, AWS Ubuntu default patch baseline. So these are the different default patch baseline. And so on. Like you can have Linux patch baseline, and we created and defined it in the same name of the OS, and then default page baseline. So for Windows it's a bit different. Patches are going to be automatically approved 7 days after the release. So as soon as the patch is done in Windows update and 7 days have elapsed, then it's going to be deployed through the patch baseline. And the way it's named in Windows is also the super important thing. It's called the AWS default patch baseline, and this applies to Windows. And what this patch baseline does is install all the operating system patch for critical updates and security updates. And there is another patch baseline for Windows called the AWS Windows Predefined Patch Baseline. So which is actually the exact same as of the AWS default patch baseline. So you just need to remember the first one, and then there is another one called AWS Windows Predefined Patch Baseline OS applications, which is on top of installing the critical updates and the security updates, and is also going to update any Microsoft application on your instances. So going into the exam, you need to remember 100% the way to apply a patch baseline into Windows. The default one is called the AWS default patch baseline. Okay, but it is also possible for you to define your own custom patch baseline, in which you define the OS you want to install, and the classification of update is like the critical update is a security update, or like the severity, high image and low kind of things. So okay, so once we define a patch baseline, which is defining how the patches are going to be deployed on a Linux or Windows system, we now actually have to deploy these patches. So you need to remember all the steps for SSM Patch Manager. The first one is to define a patch baseline to use But we have seen this, or multiple, if we are using multiple environments, for example, different versions of Linux or Windows and the Linux at the same time, then we define patch groups. And patch groups is going to be how we group our instances based on tasks. For example, for different environments, so maybe we have a dev environment, a test environment, and a production environment. So we will define a patch group to group these things together. And then we define a maintenance window, and this is a scheduled JSON and a list of registered targets and a patch group of registered tasks. And the tasks are going to be what needs to happen to this instance during the maintenance window. So the idea of the OS maintenance window is that you can define a rolling deployment of these patches one by one or multiple by multiple. Okay, and then in this maintenance window, we have to define what needs to happen. So the first thing we need to define is to add a run command called AWS run patch baseline. And so you will add it as part of your maintenance window task, and it works cross-platform for Linux and Windows. And then we will define a rate control, which is a concurrency and error threshold for the task. And finally, we can define as we can monitor the patch compliance using SSM inventory. So this may seem complicated, but the idea is as such, like you are going to create a maintenance window and register a bunch of instances through patch groups, and then you need to make sure that you can say, hey, which patch baseline you want to apply, and then within your maintenance window you need to have a run command, run patch baseline, you need to remember, and the name as well. And this is going to work across Linux and Windows instances. And then finally the patches will be applied according to the write control you do for the maintenance window. And you can manage inventory compliance through SSM inventory. A rate control you do for the maintenance window, and you can manage inventory compliance and through like SSM inventory. So finally, here is a diagram have been given. Hopefully that can help you, so that that shows everything I have outlined from before. And if you are still in doubts, please look at the blogs in the form like the AWS documentation, and there you will be able to learn more about it. This should help you. And but going into the exam, like you have to remember all these steps, and that has to like make sense for you. And you have to remember the names of run commands and the name of the patch baseline for Windows. Okay, so then we have parameter store that we have already seen earlier in some of the new previous lectures. So this is a secure storage for configuration and secrets, and we get optional seamless encryption using KMS, KSM, and KMS, that is the key management service. It's serverless, scalable, durable. There is easy SDK, and some of it is free. You can have version tracking for configuration and secrets, and all the configuration management will be using path, and we can use IAM policies to secure access to this path. We get notification with CloudWatch events for changes in the parameter store. We get integration with CloudFormation if we need to pull secrets from the parameter store into our CloudFormation template. So applications are going to be going to like access the parameter store either as a plain text configuration, in which case the parameter store will just check the IAM information of your application to make sure this configuration can be accessed, or it's encrypted configuration, in which like the case the decryption service will be done on the SSM side. And we'll also call KMS if the IAM informations are okay, and we say us like SSM to retrieve secrets from the secrets manager using directly the SSM parameter store APIs, or as I will show you in the next slide, you can even go through that option to retrieve the secrets. So here, this is the AWS parameter store hierarchy. So here is the hierarchy. So we can define principal my department as a top level, then my app, my dash app dev, then dev /, and then db dash URL, which should be, and also the db dash password. So these are the actual parameters. So db dash URL may be something which is going to be plain text, whereas db dash password may be something you want to encrypt with KMS. And now we have the same for the production environment. same db-url, db-password, and then we can roll up another app or to another department. Finally, you can reference secrets manager secrets directly from the parameter store, in which case you need to call the very special path slash AWS path slash AWS slash reference slash secrets manager slash the secrets underscore ID underscore secrets manager, or we can get the AMI IDs directly from the parameter store, and this is managed by AWS. So this will always point to the Amazon Linux AMI ID, for example. So add forward slash AWS forward slash service forward slash Amazon dash AMI dash Linux dash latest forward slash Amazon 2 dash AMI dash SVM dash x36 dash 64 dash GP2. So this is always going to point to the latest version of the Linux AMI ID, for example. So finally, all learned function, if we deploy them, we can use the get parameters to get the parameters by path API to get the parameters based on the environment. And so based on the environment variable we set for having functions, we can access either the dev environment or the production environment, and that's it. This is something you should already know. We have already talked, we have already learned earlier in the previous lectures. So that's all you need to know about even for the SSM, and hopefully you will understand everything and remember the naming. And if this is AWS, but you have to remember the naming, even for some of the some of the actions that we've seen earlier. So you have to remember the names of them. And this is it for this lecture, and I will see you in the next one.